In today's video, we're going to look at how to find the derivative of a power function. So, if we have y equal x to the power of n, and we want to find the derivative of x to the power of n, so dy on dx of x to the power of n, that will be, so we bring n down to the front, and then we time by x to the power of n minus 1. Okay, we're going to do a few example of how to apply the formula. If let's say this time I have y equal x to the power of 4 plus 5 x to the power of 2, something like that, minus 6. So to find the derivative dy on dx, so you can see x to the power of 4, basically that is x to the power of n is 4, then I just use the formula. So for this term, x to the power of 4, so you bring the 4 down, so 4 times x to the power of n minus 1, so 4 minus 1, like that, and 4 minus 1 equals 3, so you're left with 4x to the power of 3, right? So the first term is done. Derivative x4 is 4x3. Now, if you keep going, let's do the second term. So now the next term is 5x squared. So 5 is seen as the coefficient. You will always keep your coefficient is 5. And then you use the formula again to derive x squared. All right, so to derive x squared, what we do is we use the formula here. So n now become 2. So 2 is n, so 2 times x to the power of 2 minus 1, like that. So, and then you can time these together. 5 times 2 equals 10, and then x to the power of 2 minus 1 equals 1. So 10x1, which is just 10x. Okay. And finally, the derivative of negative 6, derivative of the constant is 0. Remember that. So derivative of a constant equals 0. So you don't need to plug anything. So the answer is just 4x cubed plus 10x. All right, let's do another example. Let's say this time I have y equal x minus 3 times 2x plus 7, something like that. So the thing is, when you derive something, you always try to expand them into individual terms before you can use a formula. Okay, so you can see there's a times here and there's a two bracket here. So my first step is I need to expand that out first. So because I expand, I haven't derived it yet. So I'm going to still write y equal. Then I expand that out. X times 2x is 2x squared. X times 7 is 7x. Negative 3 times 2x is negative 6x. And negative 3 times 7 is negative 21. Okay, then you simplify. So y equal 2x squared plus 1x minus 21, like that. And then what you do next is, now that you have expanded out, you're going to put that into three individual terms like this, and then you derive it. So derivative equal. Then you start with the first term. So as we say, derivative of 2. 2 is a coefficient. You keep the 2, so you never touch the coefficient. Okay, and all you do is just use a formula to derive x squared. So derivative of x squared is 2x. So bring the 2 to the front and then take one on the top, which technically 2x1, which is just 2x, right? And then plus, then you do the next one, derivative of x. So think about x is x to the power of 1. When you bring 1 to the, use the formula, so we bring x to the power 1, so bring 1 to the front, and then we take 1 on the top. So 1 x to the power of 1 minus 1, which is 1 minus 1 equal 0, and x to the power of 0 equal 1. So technically just 1. Okay, so derivative of x equal 1. And then derivative of 21, derivative of the constant is 0. You don't have to write that. So the final answer will be 2 times 2x is 4x plus 1. And you're done. All right. Now, what if we have to derive something with a fractions, negative fractions, power, or sometimes you could have a cube root of something. Now, let's say you want to derive, let's say y equal 3 on x squared, something like that, minus 1 on square root of x, right? So just to remind you of the formula, if I have 1 on x to the power of n, then you can bring n to the top. That's become x to the power of negative n. So always make that in power form first, okay? And if you have the square root or cube root or whatever root, if you have x to the power of a and b here, so x to the power of a b root, you're going to write that as x to the power of a over b. Okay. If you need to do square root of x, actually x to the power of 1 square root is 2. So you write that as x to the power of half. But usually you won't see the 1 and the 2 here. They just write square root of x. And similarly, if you have to do cube root of x, that's the same as x to the power of 1/3. Okay. If you happen to see a square root on the denominator, so if you happen to see 1 on x to the power of a b root like that, then you can write that x. So first of all, maybe we might get fractional power, so 1 over x to the power of a over b. So we convert to fraction power, then we make this to the top, that's become negative a over b, like that. Okay. So if you have 1 on square root of x, you can write that as x to the power of negative 1/2. All right, now let's get back to work here. So my first step is I'm going to make that in power form. So I haven't derived yet. I convert that to power form. Okay, so I have y equal, now make that in power form, you will have 3 x to the power of negative 2. Can you bring that to the top? Minus, so square root of x, and we say square root of x is x to the power of a half. And when you bring to the top, it's become x to the power of negative a half. All right. Then what you do is you just derive them from here. So dy over dx. So 3 is a coefficient, keep the 3, and then use a formula to derive x to the power of negative 2, which is we bring n down, so 3 times negative 2, x to the power of, we take 1 on the top, so negative 2, take 1. 3 times negative 2 is negative 6. X, negative 2, take 1 is negative 3. You can make it a bit nicer. If you want to turn the positive power, you can make negative 6 on the top, and then x negative 3, you turn the bottom, become x 3, like that. Okay. Now, so this one is done. Then we do the next term. Minus, now we're going to do x to the power of negative 1/2. What we do, same formula. So negative 1/2, we bring to the front, so negative 1/2. X to the power of, we take 1 on the top, negative 1/2 minus 1. So negative and negative become positive 1/2. And then negative 1/2 minus 1 is negative 3 over 2. And then if you want to make it into surd form, you can convert it to positive power and then make it in surd. So this can be written as 1 over 2. X to the power of negative 3 on 2, bring to the bottom, become x to the power of 3 over 2, just positive. And then make that into the surd form as 2. And then x 3 square root here, which you don't have to write this in the 2. So square root of x cubed, like that. And then negative 6 on x cubed, right again. right? We only do the last example on this formula, which is sometimes they give you a fractions and you need to expand the amount before you go. So let's say x cubed minus ax over x to the power of 5, something like that. Now, before you do anything, your first step, you're going to separate them out, make them in power form first. So y equal, so separate them as x cubed on x5 minus ax on x5, all right? Then we simplify, we make them in power form. So we have y equal x cubed on x5, index law, we take away the power, 3 minus 5 is negative 2 minus ax, x1 on x5, 1 minus 5 is negative 4, like that. And then you can ready to derive it. So you have dy on dx equal, so negative 2 you bring to the front, and then you take 1 on the top, become negative 3, minus negative 8, x negative 4. So negative 8 is a coefficient, keep it, and then negative 4 take to the front, and then times f to the power of negative 4 minus 1 is negative 5. Okay, then you have negative 2x negative 3, and then negative 4 times negative 2 is positive 32, x negative 5. You can leave your answer like that, or you can make it nicer at writing negative 2 on x cubed plus 32 on x5. Right? Okay, now we're going to learn something a bit more challenging, which is derive using chain rule. So what happens if you want to derive something like 2x plus 5 to the power of 6 or something, and you didn't want to expand it because too much to expand. So what's the methods here? So what we do is we use another formula. So fx to the power of n is n times fx to the power of n minus 1. And because you're not dealing with x, you're dealing with f of x. So when you finish, you need to time by the derivative of f of x. So this is the application of chain rule, but in a faster way. Okay. So let me give you an example. Let's say I have y equal 2x plus 5 to the power of 4 something. So you don't want to expand this, do you? Because to the power of 4 is too much. And you can see fx here to the power of n. So you can really ready to apply. So dy over dx equal, so n is 4, so 4 times f of x is the whole thing here, 2x plus 5 to the power of 4, n minus 1 is 4 minus 1, and you time by the derivative of 2x plus 5. So time by 2x plus 5 derivative. All right, so 4 times 2x plus 5, 4 minus 1 is 3. And then what is the derivative of 2x plus 5? Derivative of 2x equal 2, and derivative of 5 is 0. So technically you just time by 2. So you have the answer here as 8, and then 2x plus 5 to the power of 3. And then you're done. Okay. We're going to do another example. Let's say this time we want to do something with the negative power. So something like 5 over 3x minus 1 to the power of 2, something like that. So your first step is you always make sure that it's in power form before you can do anything with that. Okay, so to make it in power form, you're going to put that to the top, y equal 5. And when you put that to the top, the power becomes negative. So 5 times 3x minus 1 to the power of negative 2, like that. Then you can derive this. So dy on dx equal, so the 5 you keep it, and then the negative, so you use a formula to this. Okay, so if I recall the formula, fx to the power of n equal n times fx to the power of n minus 1 times f dash of x. right? So the derivative of that. So n is -2, so bring -2 down, times fx is this is f of x. So times 3x minus 1 to the power of -2 minus 1, and then times by f dash, so times by the derivative of 3x minus 1, derivative of that. So 5 times -2 is -10, 3x minus 1, -2 minus 1 is -3. Derivative of 3x minus 1 is just 3. Then -10 times 3 is -30. 3x minus 1 to the power of -3. And you're left with -30 over 3x minus 1 cubed. And that's pretty much it. Okay. Lastly, before we finish, I want to also talk about if you have to derive something with the square root, you pretty much do the same thing, or sometimes you can do cube root. So let's say 4 times cube root of x minus 6, something like that. So again, you always put in power form. So you have 4, keep the 4 as a coefficient, and then think about the whole thing here to the power of 1. So you can make that in power form of writing x minus 6 to the power of 1/3. So n in this case is 1/3. So 4 is a coefficient, keep the 4, and then 1/3 you bring to the front, and then you write f(x), which is this one, f minus 6. And then you take one on the top, 1/3, take one, and then you times by the derivative of x minus 6 derivative. Okay, so that's derivative here. So 4 times 1/3 is 4/3. X minus 6 to the power 1/3 minus 1 is -2/3. And then derivative of x minus 6, derivative of x equal 1, and derivative of 6 is go away. So technically you times by 1. And because you times by 1, you don't have to do anything with that. And with the negative power, you can make it into positive by writing. So you have 4/3 here. X minus 6 to the power of 200, make that to the bottom to positive power here. So make the negative become positive at the bottom. And then you can convert to the third form if the question asks for it. But you can leave your answer like that. So x minus 6, 2/3 means square inside and then cube outside.